line and rotational symmetry. So symmetry occurs when something is made up of exactly the same parts. Let's have a look at some line symmetry. So let's look at this isosceles triangle. Now, if I can draw a line somewhere through where both halves are the same, I have some line symmetry, and I can do one right down the middle here, where the part on this side of the line and the part on this side of the line are identical, so we can say this has one line of symmetry because there's no other line I can draw that will be the case. So we have one line of symmetry here. Let's look at a rectangle. Okay. Now with this rectangle, where this side equals this side and this side equals this side, I can draw a line of symmetry straight down the middle again. And I can also draw a line of symmetry this way through the middle, because both of those halves will be identical. So we can say this one has two lines of symmetry. Let's look at rotational symmetry. Let's use a triangle. We'll use an equilateral triangle this time. Where all three sides are the same. And for rotational symmetry, we're going to rotate the shape. And where can we stop the rotation? How many times can we stop the rotation when we have the shape in the way it sits right now? So we have one for where it is right now. Then if we can rotate this corner down to here, we'll have another one. So we'll have two. Then if we rotate this corner over here, we'll have another one. So what we say is this shape has rotational symmetry of order 3. What about a rectangle? So you can imagine a central point here, and we're going to rotate this way. So remember, we have 1 in its original position. Then if we rotate it 90 degrees, the rectangle will end up like this. But this is not in its original position, so this doesn't count. I'd have to rotate it another 90 degrees to get it to here, and that's another order of symmetry for rotational symmetry, and that's all we can do. So we have rotational symmetry of order 2 for the rectangle. What about if we have a regular pentagon? It's a hard shape to draw. But a regular pentagon has all sides equal. And what's its line symmetry and rotational symmetry? So we're after both line symmetry and rotational symmetry. So for line symmetry, we can definitely do one down the middle. And we can actually do one through every vertex going to the opposite side. So we can do one here, one here, one here, and lastly, one here. And there, we've done 5 lines. So it's line symmetry, has 5 lines of symmetry. What about rotational? If I rotate this corner to here, this corner is now up there, and every corner is moved around clockwise and we have the same shape. And I could do the same by rotating that corner to there. So that's 2, there, 3, there 4, and back to its original position at 5. So rotational symmetry has order of 5.